Hello, in these notes we are going to be looking at solving systems of inequalities and finding their solution set. So let's go ahead and start with our first example on our notes. Notice up here on the left hand side it has a statement and it says, how would you graph a system of inequalities and find the solution set? And it gives us two different inequalities, and so that creates a system. And it says, do you graph a solid or dashed line? Well, first we have to look at this symbol that's right in the middle. And I hope that you notice that this is a greater than or equal to sign. And because of that, we are going to use a solid line. Next, what we want to do is go ahead and break this up and recognize that our m is the number in front of the x and our b is going to be this last value, this last integer. Remember, m represents the slope and b represents the y-intercept. So we're always going to start graphing these by doing the y-intercept. Now I'm going to go and put a star by it. I'm going to graph this first one in black, and I'm going to graph the second one in pink. And then we'll look and see how we can find a solution, which is going to be very similar to what we did before with inequalities. It's just a few extra steps. So let's go ahead and take a look at this. We got a y-intercept of -3, so I'm going to start from origin and go down to -3. I'm going to put my first point. Now my slope is 1, so that means 1 over 1. So we go up 1 over 1. I'm going to plot my second point. Now I'm going to go ahead and I'm going to draw my solid line because it can be equal to it. It can actually touch it. Alright, so there's my first line for my first inequality. And now we're going to go and graph the second one. The second one has -1 as the y-intercept. That's my b. So I'm going to go to -1 and put a point right there. And my slope is actually -1. So I'm going to go down 1 over 1. Now I'm going to just draw over this existing dot because it happens to be in the same place. So notice that we have an intersection right there. And I'm going to go ahead and draw my line. Alright, so what we want to do is we want to find a solution set, and we want to say the solution set is, another way to say the solution set is to say what ordered pair will make all circumstances true when it comes to these two different inequalities. And so the best way to find that is we're going to choose a point from each quadrant. Imagine this as 4 different quadrants. We'll choose a point from each one, and we'll test it to see if it makes true statements for both inequalities. So the difference in this really is, instead of just looking at one inequality to see if it's made true, we have to find an ordered pair that makes both inequalities true. Now notice it says, where do you shade? Well, we're going to hold off on that because at this point we don't really know where. We can either shade in the bottom, or we could do the left or the right or the top. So first thing we want to do is go ahead and break up our box right here. Now I do want you to keep in mind, because there's 4 different places that we could shade, it is very possible that we may have to do this 4 times. Check all these inequalities to see if they're true. Most likely, usually you'll find it within the first or second try, but there is a possibility you might have to do more than one time. So let's take a look at it. I'm going to go ahead and choose one of my favorite points. I love starting with either 1, 1, 2, 2, something like that. So I'd say let's go ahead and give this a shot. We're going to go down here in the bottom. I'm going to go to -2, 2. I'm going to write this down, -2, -2. And so I'm going to use that as a test point, and we'll see what we come up with. So let's go ahead and write our inequality over here. So y is greater than or equal to, and I'm doing the first one first, x minus 3. And I'm going to substitute my value of -2 and -2 in. So we have -2 greater than or equal to -2 minus 3. So -2 is greater than or equal to -2 minus 3. That's going to give me -5. So there's one answer. And is -2 greater than or equal to -5? And I'd say, well, yes, it is. Actually, that's a true statement. So I'm going to go ahead and put true there. Now let's try it in the second equation, right? Or I should say inequality. So, alright, we're going to do this next one. We're going to do the bottom one now. Y is greater than or equal to -x minus 1. And we're going to have -2 is greater than or equal to negative. Now here's the thing, right? When you replace an x, make sure you put that value in parentheses so you don't forget to distribute that negative sign. And so if I were to distribute this negative sign, this now becomes a positive 2. right? Minus 1, negative 2, and 2 minus 1, that's going to give me a negative 1. So we can say, well, is negative 2 greater than or equal to negative 1? And that is false. So we know that it's not going to be this particular part of the coordinate plane. It's impossible. So nothing in between this section is going to be an answer. So I'm just going to go curve around and go to my next favorite point. I'm going to go up to positive 1, 1. So let's try 1, 1. Alright, so I'm going to rewrite this. So we got y is greater than or equal to x minus 3. And we're going to replace the y with a 1 value and the x with a 1 value. And we have 1 is greater than or equal to 1 minus 3, that's negative 2. And that is a true statement. So just like the last time, we end up being true again. And so I'm going to, okay, well now let's check the second one. So I'm going to go, okay, y is greater than 2 negative x minus 1. And I'm going to go and substitute my numbers. 1 is greater than or equal to negative 1 minus 1. So 1 is greater than or equal to negative 1 minus 1, which would be negative 2. Now, some of you might be looking at going, Mr. H, you are working this out like one step at a time. I am, because I want you to see the process of doing this by hand. And 1 is greater than or equal to negative 2. So this is a true statement. Because I have a true statement here and a true statement here, I know that this is where all my solutions will be. So my solution set is 1, 1. That makes both inequalities true, and I'm going to shade that area now. So any point that's in this area will make it true, and any point that is not will not make it true. All right, and we're done. So where did we shade? We shaded the top. All right, now with that being said, I want to mention something that some of you may not have picked up on because I didn't say it explicitly, but I want you to know that when I got this one true right here, this first one, it was true with the point being up here, I know that it had to be on top. Because when you get one of them true, if it's on top of one of the lines, then you know that most likely it's going to be the other top side that's going to make it true both ways. So in other words, I knew not to go ahead and go down here to the bottom and try it. So this is kind of just one of my methods. If I get one that's true, then I'll go ahead and look at that and go, okay, well if the top side was true on one side of this, well now I'm just going to go to the opposite side of it. So I usually first try to figure out if it's top or bottom, and then I try to figure out is it going to be the left side or right side. That's just my personal opinion. If that confuses you, don't worry about it. You can try a point in each section and you will find one always that ultimately gives you two true statements with both inequalities, and you know that it's the correct answer. So let's go ahead and go to the next one now. Alright, on this one we run into a bit of a challenge. Notice it says, how would you graph a system of inequalities and find the solution set? However, notice this is not in slope-intercept form. Now we ran into this when we were doing inequalities previously, and we had to change these from standard form to slope-intercept form. So that means that we got a little bit of extra work to do on this particular problem. And you could run into a problem like this. So let's go ahead and start. I will be doing this top one right here on the top in this space I left above, and I will do the one on the bottom in the space below. Now I do want you to notice that this does use a less than and greater than sign. So when it says, do you graph a solid or dashed line? In this case, we're going to be graphing a dashed line because it's not equal to, correct? It's just less than or greater than. So let's go ahead and move this value up to the top, this inequality, and let's work it out. So we have 4x, and I'm going to move this over so you can see it a little bit better, minus 3y, and we have that is less than 9. Alright, so if I want to change this over to slope-intercept form, I'm going to go ahead and just move a few things around. First thing that I want to do is I want to go ahead and move my negative 4x over. Those cancel out. I'm left with negative 3y is less than negative 4x plus 9. I need to get rid of this negative 3. Now here's the key. Remember, when you're dealing with an inequality, if you divide by a negative integer, or a negative value for that matter, then you're going to go ahead and have to flip the sign. So we're going to have a sign flip right here. So I'm going to go ahead and flip it so I don't forget, because if I don't do that ahead of time, a lot of times, me personally, I'll forget. And I'm going to go ahead and bring my -3 over here and bring my -3 over here. Now notice I did make it like two separate fractions. That's because there's an addition sign. If you have an addition or negative sign or minus sign in between two terms, you always want to go ahead and make sure you put that 3 under both instead of drawing a single line and put in 3. I see people when they put a single line and they'll put that -3 underneath, they'll just divide it into one of those values and they'll make a mistake. So -3 divided by -3 is +1. So we have a +1y left over. -4 over -3 turns into a +4 over 3x. And 9 divided by -3 gives... This is a -3. Let's do the bottom one now. So we have x plus 3. Y is greater than 6. So I'm going to go ahead and subtract my x from both sides. That cancels out. Bring down my 3y. And that's going to be is greater than -x plus 6. Now in this case, we're not divided by a negative number, so we don't have to flip the sign. But we do have to divide out that -3. So I'm actually going to extend this over to the right and rewrite it. So 3 going to 3 one time, that leaves me with y is greater than -x over 3. So that's going to be -1/3 x. And then we have 3 going to 6 two times, plus 2. Alright, so now we got our second inequality. So now that we got them in slope-intercept form, it'll be very easy to graph it. So let's go ahead and do that. I put -9. Let me rephrase that. That was supposed to be -3. It was -3 because 3 going to 9 3 times. So it's -3. So I'm going to go ahead and find -3 on my axis. Put my point for my y-intercept. Now my slope is +4 over 3. So I'm going to go up 4. 1, 2, 3, 4 over 3. 1, 2, 3. Put a point right there. Now notice this does have to be a dashed line, so I'm going to draw a dashed line on it. So when I use a pencil, a lot of times what I'll do for my dashed line is I'll draw a straight line and then just erase parts of it. But with a pen, you can't erase, so you got to make sure you put the dashes ahead of time. Alright, so now let's go ahead and graph the second one. I'm going to do that one in pink. My y-intercept is +2, so I'm going to find a +2, put a point. My slope is -1/3, so I'm going to go down 1 over 3. 1, 2, 3. Notice it actually intersects with this point right here. So I'm just going to kind of go around it with a different color pen to show that's it. And I'm going to draw my dashed line. Alright, there we go. So now what I want to do is I need to find out which one of these quadrants, right, so either the top, left, bottom, or right, has my solutions. And then we can go ahead and write our solution up here. So I'm going to get that ready to write. I'm going to cut this in half because usually it takes me at least 2 times to figure out which one is correct. I'm going to start with one that I feel is pretty easy. I'm going to go down here and do -1, -1. So -1, -1. I'm going to start there. Now looking at these, instead of me using the slope-intercept form, I'm actually going to go ahead and use this bottom one. It has a coefficient of 1 for x, and it looks fairly simple. I'm going to use the x plus 3y is greater than 6 and just substitute these numbers in for it. So I'll do that in pink. So we have x plus 3y is greater than 6. So we know for x we're going to substitute a -1. And 3 times y, which is also -1, and that's greater than 6. So I can distribute now. So I have -1, and 3 times -1 gives me -3, and it should be greater than 6. So that'll be -4 is greater than 6. Now I'm looking at this right now and I already go, you know what, this is false. -4 is not greater than -6. So I know that this no point in this particular part is going on my coordinate plane is going to represent a solution. So I'm going to go clockwise. It's just something I prefer to do. So I'm going to go up here and do this one now. So let me find a point up here that will work. So I'm going to do, it looks like 3, 3. I think that's an easy one to test. 3, 3 is still a small number. And I'm going to try this again. So right, we have x plus 3y is greater than 6. So if I substitute 3 for x, and I substitute positive 3 for y, 3 times 3 gives me 9, so 3 plus 9 is greater than 6. That would be 12 is greater than 6. This is true. So I'm looking good so far. Let me go ahead and try the next one. So now I'm going to use this one. I'm going to use it in standard form. 4x minus 3y is less than 9. So let's substitute our values. We have 4 times x. Well, x is 3. Minus 3 times 3. That should be less than 9. So 4 times 3 is 12. Negative 3 times 3 is going to be negative 9. And 12 minus 9 gives me 3. And 3 is less than 9. That's true. So I have found my solution set. My solution set here is 3, 3. And I know that everything up here is going to be an answer because it made both inequalities true. So everything up in this top section is going to be an answer choice and make the statements true. So let me go ahead and just going to highlight it all. So notice in this one I didn't check the second one to see if it made it true on one side so I could figure out what side would be most likely the correct answer. I just decided to go clockwise. And I'll do that frequently as well. So you can do it either way that you like. Worst case scenario, you have to test 3 different ones before you find the correct one.